All right, welcome to this lesson on solving linear systems by substitution. So at this point, we have solved linear systems by graphing and by elimination, and this time I'm going to do it by substitution. Okay, and I find that the easiest way to do these is, of course, show some examples and describe and explain what I'm doing as I move along. Okay, so once again, I have my trusty pen available to me, and I'm going to tell you that these work best, and I would recommend the use of them whenever we have at least one equation in slope-intercept form. Okay, if you don't, if both equations are given to you in standard form, usually I would revert to elimination, but I'm going to show you that you can do them by substitution as well. So when you do questions later on where you have a choice, that's important to note. So really important you understand the difference between standard form and slope intercept form. So this first equation is in slope intercept form. It's y equals x plus 4, and that tells me that the slope is 1 and the y-intercept is 4. And so that there is the very first equation. The second one is 3x plus y equals minus 4, and that's standard form. It doesn't really tell me a lot in standard form. I can't just look at it and see the uh, intercept and slope as easy, but that's the way the question is given to us. So I'm going to work on this one here. I'm just going to scroll it down a little bit so that we can see it better, and I'm going to make it a little bit bigger just so it's easier for me to write on the screen. Okay, so, oh, my bad. Just give me a second here, erase this nasty line, and I will use the mouse here. Okay, so the first thing I'm going to do is label the equations again. Okay, so each equation is going to be labeled. Okay, and do that by giving this one the name A and this one the name B. Now, when I look at this one, I see very easily that this is what y equals. This tells me what y equals. What I'm going to do is I'm going to take this y value of x plus 4, and I'm going to replace y here with x plus 4. And that's why they call it substitution. So essentially what I'm going to do is substitute the value of y into b, where y is in B, okay? So what we do is we make a statement, and this is important. We're going to apologize, the computer sometimes wants to jump around on me here, so give me a second here. Sub A into B. I'm literally going to substitute the y value into B. And sometimes I'll put a y because I'm telling you what part of it that I'm substituting. Okay, so AY is going to go into B sub. And think of it like a substitution in hockey or soccer. You know, one person comes on, another person goes on. Well, Y is going to change, okay? But instead of putting Y in for Y, we're going to change Y to be X plus 4. And let me write this out like this. So I go 3X plus, and now I'm not going to write Y, I'm going to write X plus 4. And the common standard is 2, and that will equal minus 4. So essentially, this is the same line here. The difference is between this line and this line is that where the y was, I've now put x plus 4 because that's what the y value equals in the equation A. Now, I always put it in brackets. If there's a number in front of the y, like we'll see in other questions here, it's important. In this case, it's like a 1 that's here because like we know that this is 1y. We just don't usually write it. And then I use my distributive property to get rid of my brackets, okay? So in this case, I don't have anything to do. It just becomes 3x plus 1 times x is x, and 1 times 4 is plus 4 equals minus 4. Now I want to solve. So I can collect my like terms here. X and 3x are like terms, so they can be added together. And I don't want the 4 on this side, I want it over here, so I go minus 4, and I minus 4. And this leaves me with 4x equals minus 8. And I'm almost done solving this, but I have to divide both sides by 4, okay? And hopefully by now you're getting better at solving equations, something we did earlier in the course, and you're using these skills to help us solve these equations. So this equals x equals minus 2. Now I have basically solved half of my equation. So I just clean up some mess over here. I have half of my solution in that I know the x value of where these two lines cross is minus 2. Now I'm going to take this here, and I'm going to go up to the top here, and I'm going to sub x equals minus 2, and I can sub it into either one. If one of these is a slope-intercept form, I always choose that. It's just so much easier, right? Because the way it structures it. So I'm going to sub that into A, because A is in slope-intercept form. If they're not, then you have to kind of pick and choose which way is the best way to go. So I end up with y equals, and not x, but minus 2. So minus 2 plus 4, and that equals y equals 2 when I do the math there. Now I have my point. I have my x value of minus 2, my y value of positive 2. So I write my therefore statement. Therefore, the POI, point of intersection, because remember, anytime we're solving linear systems, that's what we're looking for, is, and it's a point minus 2 and 2. And we're all done. Questions finished. Substitution really works slick when you have one that is slope intercept and one that is standard form. Really like it for that. Here's one though that we don't have that. So I want to look at this question and I'm going to solve it. And what I'm going to do is identify which one I would like to solve for y. Okay, so if I look at this one and I say I want to solve one of these for y, so I'm going to first label them. Okay, so I'm going to call this guy A and this guy B, just sort of my standard, if you haven't figured that out yet. And it's clear to me that because there's a 3y here and here it's just 1y, that this would be easier to solve for. So if I'm going to do that, I'm going to say solve for by. And in this particular case, I'm going to add 2x here and add 2x here. And what I end up with is y equals 2x plus 4. So what I've done is I've rearranged b so that it is in by form. Now I can do the same thing I did in the last question. I can take this information here and I can substitute it in for the y right there in A. And so what I've got to do is I got to say sub by into A. And when I do that now, I simply write x plus 3. And now instead of putting y in here, I'm rewriting A out, okay? I'm going to write in 2x plus 4. So 2x plus 4 equals minus 9. Now I can go through my expansion and remove my brackets to get rid of it. Now I have a number in front. Last time we had just a 1, so it didn't really matter, but this time I have a 3. So I'm going to go 3 times 2x and 3 times 4. And so I'm going to get up x plus 6x, because 3 times 2 is 6x, and then 3 times 4 is plus 12, equals minus 9. Now I'm going to solve all this, bring things together. So if I have x's, they come together. That gives me 7x, and I'm going to subtract 12 here, and I'm going to subtract 12 here, and this will equal minus 21. And if you don't believe me, get your calculator out. Minus 9 subtract 12 is actually minus 21. And to finish the solving, I have to divide both sides by 7, and I get x equals minus 3. And I have half of my solution complete. Because I always make a mess over here, I'll just do some erasing. Okay, half of my solution. I know what half of it is. So now I'm going to go like this and come up here and say, now I'm going to sub x equals minus 3 into, and I have to pick one of A or B. Okay, so in this particular case, I'm going to actually choose, it really wouldn't matter. I'm going to choose B or A because the x is by itself. It just makes it easier for me. I don't have to multiply it by anything. Okay, and so I'm just going to select A. And so I end up with minus 3 plus 3y equals minus 9. So I have to add 3 on this side, add 3 on this side. This gives me minus 6, 3y. Those two cancel each other off. Divide by 3, and y equals minus 2. And I have now solved for my point of intersection. So all I have to do is put a therefore statement. So I write therefore the POI, point of intersection, is x is minus 3, y is minus 2. And I have found my point of intersection. There's one more example that we're going to do. Oh no, that's it. I'll just leave it at that. Most of the questions I believe that you're going to get are of this format where we have at least one in slope-intercept form. Okay, and then you have a fairly easy solution. Sometimes they're both in slope-intercept form, which makes it really easy. And I'll let you work on that. Again, if you have any questions, please email me. I'll be glad to give you an example or help you out.